The whole quarter. Okay, I'm recording, just so you know. We've got sequences and series for section 9.1. We're going to do 9.1 for today, Tuesday, and part of Wednesday. So the first part is just vocabulary. Sequence is a function whose domain is the set of positive integers. The domain is the input. The domain is like the x values. That's what comes first. Positive integers start with 1, then 2, then 3, 4, 5, and so on. That domain, the set of positive integers, that's like which term it is. The input is the first term, or the second term, or the third term. So here, this is showing you f of 1. That's saying in the function we're putting in 1, and then we get out a sub 1. So the subscript, I just thought of something. The subscript is like a little number at the bottom, and it doesn't change the number. It just tells you which term it is. So a sub 1 is the first term, a sub 2 is the second one, a sub 3 is the third term. A sub n would be like the general formula for all of the terms, which we will be finding that tomorrow. A finite sequence is a sequence that ends, or if we know what n is, like if there were 10 terms, then that would be finite. And infinite goes on forever. And then I already used the word in here, but each of those is called a term. Okay? Okay, so find the first 5 terms of the sequence. We are purposely, on purpose, going to show our first step. We're going to show work for this, even though I know you can do some of this in your head. It's not a challenge to do in your head. We want to purposely show the work so that helps us do the general term tomorrow. Has to do with patterns. Oops, I went too far. We're purposely going to show the work. So this is what I want to see in your paper. I want to see a sub 1. From there, I want to see that that is 5, and then 1 is n minus 3. And then 5 times 1 minus 3 is 2. So we're going to do a sub 2, and we're going to do a sub 3. We're doing the first 5 terms. So we're going to do through a sub 5, and we're going to show all our work. So the second one is 5 times 2 minus 3. So we've got 5 times 3 minus 3. 5 times 4 minus 3. And 5 times 5 minus 3. And when we write our answer, we write it as a list of the terms in order with commas. Do you notice any patterns when you look at either the work in blue or the answer in red? Is there anything that you notice? What kind of patterns do you notice? What, Michael?
Like 8, like 2, 7, 2, 7. That's what
Oh, 2, 7, 2, 7, 2, 7? Yeah. Each time it's going up by 5, every single time. Mm-hmm. Okay. So the next one, find the first 5 terms of this sequence. So this one's got some n's in different places. So we're going to do a sub 1 equals negative 1 to the 1, and then 1 squared. A sub 2 is negative 1 to the second, and then negative 2 squared. Not negative 2, 2 squared. Sorry. A sub 3 is negative 1 to the third, and then 3 squared. So we do -1 to the first is -1 times 1 squared. -1. Then we get -1 squared, that's 1 times 4. So I put a little note to notice what the -1 to the n is doing. How does that affect this pattern? It's making every other term negative. So tomorrow, you're going to be given the terms that I give you in red. You're going to be given that, and you have to find the general term. So if you just happen to notice every other number was negative, it would probably have something like this in it. Tomorrow, there's not going to be like a set rule that works for every single one. You're just going to have to kind of guess around and check to make sure you figured out the pattern yourself. So having tips like that -1 to the n makes every other number negative is helpful for tomorrow's lesson. What is something else that we notice about this pattern? They're all perfect squares. Because it says n squared. So all of them are perfect squares. There is something else that's interesting. I don't know if you've done this in another class. If we just look at 1, 4, 9, 16, 25, just look at those. Do you know what the differences are? 3. It's supposed to say 9. Do you know what the differences are from those? No, it's not writing. It doesn't want to write. There we go. Okay. Next says find a sub 5. So do I have to do all 5 to get to a sub 5? Just do it that time. Ooh, well, what is that on top? Factorial. I'm going to explain factorial in the longest way possible, but I'm only explaining it this way so that you know what to do when there's variables and not numbers, okay? If you remember factorials from before, you take 5 and then you multiply by, how do you get 4? So we take 5 and we do what to it? We subtract 1 to get the next number down. So I'm showing this like the longest way possible. That's only because we're going to do this with variables. And if you just know how to do it, like if you just know how to plug it in your calculator, you have no idea when it comes to variables. So that's why I'm purposely explaining it really long. So I would multiply 5 times 5 minus 1 times 5 minus 2, because we're going to subtract 1 each time, times 5 minus 3, times 5 minus 4. Do I do one more? No, because if I did one more, that would be 0, and factorials don't give you 0, they actually give you a number. Now, I would not, if I were actually doing this problem, write it that way. I'm just doing that for explanation. What I would write on my paper is I would just write 5 times 4 times 3 times 2 times and stop at 1. Doesn't go negative, doesn't go to 0. Another thing that you might remember about factorials is if there's no addition or subtraction in here, you can cancel stuff. So I could cancel 5 and 2 with 10. So I don't actually have to multiply all that and divide by 10. I can just cancel those out and get 12. So a sub 5 is 12 would be like my answer for that one. Yeah. It's on the next page. That's why I was doing it. Okay, so that's part of what your assignment's like. The rest of your assignment is just doing a few things with factorials. It's kind of random that factorials are thrown in here. Those are really used with like probability, but there's someone to do it, so let's do it. So with the first one, 3 factorial over 7 factorial, there is a long way of doing it and there is a shorter way. Neither of them involves the calculator. Maybe eventually involves a calculator, but so this is the longer way. I would say 3 factorial is 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then I would say, oh, the 3's cancel out. Oh, the 2's cancel out. Oh, the 1 doesn't really cancel out, but cancels out. And that's the long way. The shorter version of that would be, what really canceled out on top and bottom? It's 3 factorial. That's what canceled out on top, and that's what canceled out on the bottom. So what I should do, instead of writing all the numbers out, if you look at the next one, there's no way I'm writing all those numbers out. I'm not writing all those numbers out. So on this one, what I should do is just look and see which one's bigger. And whatever one's bigger, start writing that one in descending order. Start doing the factorial, expand the factorial. 8. Expand factorial of the bigger one. Of the bigger number. And then leave the smaller one there. So if I start expanding the factorial of the bigger one, I do 7 times 6 times 5 times 4. And then as soon as I get to 3, the same as the top, it's exactly the same as the top. I don't need to write all the numbers out. I can just cancel there. So we're just going to extend the bigger number. Stop when you match the smaller number and then cancel at that point. And here, if you need to use your calculator at that point to do 7 times 6 times 5 times 4, that's fine. I think it's 840. What's on top?
1.
Okay, if the top cancels out, you do need to put a 1 there. You don't just write 840. That's not true. So when we go to do this one, I'm going to do it the shorter way. Which of the two am I going to actually extend? The bigger one. Which one? 100. So I'm going to write 100 times 99 times 90. Ooh, it matches the bottom. So I write factorial. And then I can cancel them. So you just extend the bigger one. Now, I want to look at the fourth one next, because that one's a little easier than the third one. Fourth one, you look at 5n plus 1, and you look at 5n, which is the bigger one. The bigger one is the top one. That's the bigger one. So I'm going to extend the top. I'm just going to leave the bottom one as 5n factorial. So if I extend the top, I'm first going to write 5n plus 1. The next thing I write is 1 less than 5n plus 1. So this is what I'm thinking. I'm going to erase it and actually write it, but I'm thinking 1 less than 5n plus 1. Well, that's just 5n. And doesn't that match the bottom at that point? So we write factorial. And then we cancel it. And our answer is just 5n plus 1. So you go back to 3. Which one's the bigger one? Denominator, because the top one's -2, so it's got to be smaller. So we're going to extend the bigger one. So I'm going to keep the top n minus 2 factorial. On the bottom, I'm going to first write n, then I'm going to multiply it with 1 less, n minus 1. Does that match? No. So then I got to do 1 less, n minus 2. Does that match? Okay, so then we can write factorial. And it would continue on from there, but I don't know how far it goes because it's an n and I don't want n. So those will cancel. What do I write? 1 over. Now, the book just leaves it factored. If you feel like multiplying it out, feel free, but this is for the way the book makes sense. All right, and that's all we're doing today. Remember, you're showing all your steps. You're showing all your work for those first few. And I'm going to come around and check your work as you're going.